Good day, learners! Welcome to another episode of Teleradio-based instruction. This is Teacher Giselle of F. Bangoy National High School, and you are watching Math 8 on air.
Just a few reminders. Please make sure that your headsets and speakers are working. Be on a quiet and comfortable place. Lastly, have your Math 8 module with you.
Last week, we have learned about the 3 different ways of factoring polynomials. Do you still remember them? Very good! They are factoring by greatest common factor, by difference of 2 squares, and by the sum and difference of 2 cubes. Today, we will be learning more ways of factoring polynomials. These are factoring perfect square trinomials and factoring general trinomials. We will also apply these techniques to solve worded problems. I know that this may sound difficult and may scare you away, but don't worry, I will be teaching you the step-by-step process to make this lesson simpler and easy to follow. Are you ready? Wonderful! Get your pen and paper handy as we begin today's lesson. Can you still recall what a perfect square trinomial is? Correct! A perfect square trinomial is the result of squaring a binomial. They would normally have one of these 2 forms. A perfect square trinomial has 2 characteristics. 1 is that its first and last terms are perfect squares. And 2, it's that its middle term is the product of 2 times the square root of its first term times the square root of its last term. If you are able to verify that a trinomial has these 2 characteristics, then factoring it would be as easy as a breezy. Let us take this trinomial as an example. Does this trinomial have the 2 characteristics of a perfect square trinomial? Definitely! The first and last terms are perfect squares, and the middle term is 2 times the square roots of the first and the last terms. Since this trinomial is indeed a perfect square trinomial, we can take the square roots of the first and last terms and copy the sign of the middle term. This binomial is the factor that we are looking for. Multiplying this binomial by itself should result back to the perfect square trinomial. Let us take a look at this. What if the given trinomials are like these? Are these perfect square trinomials? If this is the case, then we have stumbled into general trinomials. General trinomials are classified into 2. One is where there's no leading coefficient, and 2 is where the leading coefficient is not equal to 1. Factoring the first classification, is done in 2 steps. The first step is to find the factors of the last term for x to the power of 2 plus 3x plus 2. The factors of 2 are the following. Second is to check if the sum of these factors is equal to the numerical coefficient of the middle term, which is 3. As what we can see, the factors 2 and 1 is the correct combination. Therefore, our factors for the trinomial x squared plus 3x plus 2 are the quantity of x plus 2 and the quantity of x plus 1. We can check our answer by multiplying the 2. Factoring general trinomials when the leading coefficient is not equal to 1 can be quite challenging, but still doable. We have summarized the process in 7 easy steps for you. Let us take 2x to the power of 2 plus 5x minus 3 as an example. Step 1 is to multiply the leading coefficient and the constant. This example will give us a product of negative 6. Step 2 is to list down all factors of the product from step 1. In this case, we'll list down the factors of negative 6. Step 3 is to check if one of the factors will have the sum that is equal to the numerical coefficient of the middle term. For our example, the sum should be equal to positive 5. From our list, only positive 6 and negative 1 resulted to the sum of positive 5. Therefore, this is the correct combination.
Take note that if no factors will satisfy step 3, we can consider the trinomial as a prime and as a different way of factoring. But this will be discussed in another lesson.
Step 4 is to write the correct combination as our temporary factors. Then step 5 is where we are going to divide them by the original leading coefficient. Do you know what is the leading coefficient for this example? Good job! Our leading coefficient is the number 2. As such, we'll have the quantity of x minus 1 divided by 2 times the quantity x plus 6 divided by 2. For our step 6, we are going to reduce these fractions to their lowest terms if possible. In this case, we cannot reduce negative 1/2 anymore, but we can still reduce 6/2 to 3. And finally, we are down to the final step, which is to transfer the remaining denominator and place it in front of x. We now have the final factors for the trinomial 2x squared plus 5x minus 6. To check if this is correct, let us multiply the factors. Doing, learners? Let us all take a 3-second breather before we continue our lesson. Inhale, exhale. Our last topic for today will be about solving problems involving factoring of polynomials.
One day, your mother asked you to make her a rectangular shaped garden. The total area of the garden should be 84 square feet. She wants the length of the garden to be 8 feet longer than the width. Can you tell what is the length and the width of the garden? This problem wants us to find the length and the width of a rectangular garden that will fit in an area of 84 square feet. Before trying to solve the problem, let us try to remember the formula for finding the area of a rectangle. Can you still remember it? Awesome! For a rectangle, its area is equal to the length times the width. Now, we are ready to solve the problem. At this point, I will be teaching you how to solve this worded problem following 3 major steps. First step is to assign a variable that will represent the number that we are trying to find, and that is what we call the unknown. Do you know what we're trying to find? Very good! We are trying to find the width of the garden. Although the problem is asking for the length and the width of the garden, we were given a hint as to how long the length should be compared to the width. Therefore, we need to find the width first, and this is our unknown. Let us assign the letter W for our unknown to help us remember that we are trying to find the width of the garden. Second step is to translate the words from the problem to mathematical symbols. Let us use the formula as a guide. The problem says that the total area is 84 square feet. Therefore, we can replace A with 84. Then, the problem says that the length of the garden is 8 feet longer than the width. So we can replace length with W plus 8. Since we don't have words to translate anymore, we can now proceed to the third step, which is to simplify the equation to solve for the unknown. In simplifying the equation, let us multiply W to the quantity W plus 8 following the distributive property of multiplication over addition. This will give us 84 equals W squared plus 8W. Next is, we need this equation to be equal to 0. To do this, we will have to gather all numbers and variables into one side. For this example, let us all gather them on the right side. Do you know how we can do that? Excellent! Using the additive inverse property, let us add negative 84 to both sides. Doing this, we'll have 84 plus negative 84 equals W squared plus 8W plus negative 84. From our previous algebra lessons, we learned that adding a negative number is also the same as subtracting it instead. And so, we'll have 0 equals W squared plus 8W minus 84. Then let us find a way to factor the resulting trinomial. Do you have an idea which factoring technique to use? Correct! We are going to use the technique in factoring general trinomials. Let us take a look at this. From this point, let us handle each factor separately following the zero product property. Hence, we'll have two resulting equations. The first is 0 equals w plus 14, and the other is 0 equals w minus 6. Let us now solve the first resulting equation. Since this is an equation, 0 equals w plus 14 is also the same as w plus 14 equals 0. Now, you may actually skip this step, but this is necessary to keep our solution clean and orderly. Next is to keep the variable on the left side and the numbers on the right side. How are we going to do this again? Exactly! We are going to use the inverse property of addition. Hence, we will add negative 14 to both sides of the equation, making it w plus 14 minus 14 equals 0 minus 14. Simplifying this, we'll have w equals negative 14. Are you thinking what I'm thinking? Are you also thinking that we cannot have a negative answer? Brilliant! You have the making of a mathematician. It is indeed unacceptable for us to have a negative solution for our width. Therefore, we're going to drop this solution and proceed to our second resulting equation. Our second resulting equation is 0 equals w minus 6. Again, we will write this as w minus 6 equals 0. After this, we'll follow the inverse property of addition and add 6 to both sides of the equation. This will give us w minus 6 plus 6 equals 0 plus 6. Simplifying further, we'll have w equals 6. Can we accept the solution now? Yes, 6 may be our answer. However, since we are mathematicians, let us double check if our answer satisfies all the requirements from our problem. Since we already know that the width is 6, we can now replace w with 6. Now, we can solve for the length, which is 6 plus 8, since the problem states that the length is 8 feet longer than the width. Hence, 6 plus 8 equals 14. Therefore, our length is 14 feet. Your mother wants her rectangular garden to have an area of 84 square feet. Is 14 times 6 84? Perfect! 14 times 6 is indeed 84. Since we're able to satisfy your mother's requirements for the garden area, we can now say that we have indeed solved the problem.
That's it for today, learners. I hope that you were able to learn a few things from today's Math 8 on air. Don't forget to answer your activities on your modules because the only way to get better in math is to practice, practice, practice. If you have questions, your assigned Math 8 teachers will be happy to assist you. Once again, this is Teacher Giselle signing off.